Hello everyone, welcome back to my channel. So today I've come with a new video, but today's video is not going to be on an individual chapter. Today's video is going to be a mixture of all the chapters. Why? Because today I'm going to discuss important formulae in physics. Now basically the important formulae will be of class 9 ICSE following concise book, okay, in physics, and in total we have 10 chapters. Henceforth all the important formula of from all the 10 chapters will be discussed with interesting topics and in an interesting way, as well as all the formulae on which the chapter is based. Those formulae will be explained nicely. Okay. Also, the important small topics which are associated with the formula will also be explained. One more thing is that just in the beginning I want to say that if you match the formula with the book, you will find that many formula are omitted. Now there will be two reasons for that. Either the topic which is associated with the formula is very detailed one. It needs a lot of time for its explanation. Henceforth, in that case, I am not going to include that formula today. Obviously, with those formula, I'll make a separate video where I'll explain them nicely. And another reason can be they are not so important. That's why I'll not cover. Henceforth, today's video, only those formulae will be concentrated on which the main 10 chapters are based on. Chapter wise I'll go. Don't worry, be relaxed. Okay, the people who have just come to class 9, for them it's going to be it's just like a blockbuster kind of a thing, because it's going to be a tough one. Okay, so my only motive to make today's video is that in order to make class 9's concept easy, little bit easy in the beginning only. Okay, so let's proceed with chapter 1, that is measurement. I have all the formulae listed with me, so accordingly I'll go. Okay, first formula is T equals to 2 pi root over of L by G. Now on this formula separate video is already made. Link will be given in the description. It is basically formula of pendulum. Okay. On this I have made a separate video where I have explained only this formula. Once again I am saying in a brief, T here refers to time period. T here refers to time period. 2, nothing to write. Pi, either value of pi you can take as 22/7 or 3.14. L here refers to length of the pendulum. Now what is this length of the pendulum? Basically, if I very brief, if I say, then suppose this is the fixed point from where a bob has been suspended using a rigid string. Then from this point, hope you can see, from this particular point till the center of gravity of the bob, from this point, this full thing is your length, represented by L. So L, length of the pendulum. Another your G. We all know what is G. Acceleration due to gravity. Now confusion arises here. What is that confusion? The value of G. We have two values of G. 9.8 meter per second square. 10 meter per second square. Okay. Now the question lies what to use, 9.8 or 10. In all the cases, we have to be sure with one thing. In all the cases, we will use 9.8 meter per second square. All the cases. Exception, the question will say, means if by chance this is the value that is to be used, it will be mentioned in the question. Apart from that, all the questions which we will be solving using this formula or any formula, upcoming formula, most of them will contain G, acceleration due to gravity. So everywhere we will use by default 9.8 meter per second square. But if by chance the question says that no, use g means 10 as the value of g, at that point of time you are free to use g. At that point of time, if you use 9.8, marks will be deducted or the numerical will go wrong. Answer will not match. Okay? Maybe your answer will be correct, but according to the marking scheme and according to the answer script or the answer sheet prepared by the counselor, prepared by the teacher of your school will not match. Henceforth, wherever 10 has been mentioned, use 10. If nothing is mentioned, then use 9.8. Okay? And if by chance there are questions where it will be mentioned, use 9.8. So there it's already given. So this formula is basically used when you want to find the time period of a pendulum. Okay? Then what you will do, 2 into pi into root over of L by G. Now a small trick here. You will face difficulty while solving like this. Why you know? Because you have root over of L by G. You have this root over of L by G, right? People will face difficulty here. Because everyone is not accustomed with the calculation of root over. Hence, even I do make mistake while calculating using this. Hence, we have a small trick. What is that small trick? We square both the sides. After squaring, what we do? Now, you will after squaring, we will find the answer in the form of t squared. Again, we will have to find the square root. But there you can perform normal prime factorization. If you, at the end, what your answer will come in with respect to t square, that is time period square, but you need time period only t. T square equals to t square equals to t into t. You need not to have the answer in this form. You want a single time period. You don't want the square of time period. So in that case, you can perform simple prime factorization. But here, suppose any odd value means odd, not odd. If any suppose abrupt value comes, okay, suppose in a very bad decimal or bad fraction comes which does not allow you to find which does not allow prime factorization, or it's not a perfect square or something, then at that point of time you will face difficulty. That too, it is in the form of division. Okay, working with only t square, only one value is okay, but in such a division form we are finding the root over, that is sometimes difficult. Okay, those who are accustomed, most welcome to do in this way. But if you want to make this thing a bit simpler, then my suggestion will be to square both the sides. Okay. Next formula is t equals to, I'm writing this side, 1 by f. What is t? T is again time period. This is chapter 1, that is measurement. Okay. F is frequency. Now what is time period and what is frequency? Here also time period, here also time period. Time period definition is same. Obviously, if you have watched my video of sound, where I have explained sound broadly, then there I have explained all these terms. Again I am saying, time period is the total time taken by a oscillation to be completed, or for one oscillation to be completed. The total time taken, that is your time period. What is time oscillation? One wave, you can say. Okay. Suppose if I take a pendulum, these are the two extremes, these are the two amplitudes. So completing one full wave makes it means the total time in order to complete this full wave is the time period. And what is frequency? Frequency is basically the number of waves which are created or which are produced in 1 second. Number of waves produced in how much second or how many second? 1 second only. Okay. Now the formula says T is inversely proportional to F. Why? Suppose, now imagine one wave. This is the waves. These are the waves. Okay. Imagine one wave. The time period of one wave is 1 second. So for one wave, 1 second is required. So in how many waves are created in 1 second? 1. If you are still having confusion, I am saying once again. Time period is 1 second. So in 1 second, and so what will be the frequency of that particular wave? Or what will be the frequency here? Frequency will also be 1. The reason being, frequency is the number of waves produced in 1 second. And one wave is created in 1 second, since for that particular wave, 1 second is required to complete the oscillation. So in 1 second, one wave. So frequency is 1. Frequency, the unit is either hertz, or we can also say second inverse. S to the power minus 1. S represents second. And suppose in the same time, if suppose time period is 0.5 second, then frequency will be what? 0.5 second, one wave. That means 2 waves, 1 second. So 2 waves will be created. So 2 hertz or 2 seconds square inverse. Understood? Henceforth, see, more the time period, lesser is the frequency. More the frequency, lesser is the time period. Henceforth, they are inversely proportional. So more the time period taken by a wave, less number of waves will be produced in 1 second, or we can say less frequency. Done. Only these two formulae is very important from the first chapter. Now, in the first chapter, we have vernier caliper, we have screw balls. If you come, there are 3 exercises basically. Exercise A, B and C. In exercise C, we have pendulum, which I've taught right now. There you have only these two formulae important. First, you have all the relations between smaller units, bigger units, mass, and then we have many things. Okay, so all the relations. There you have numericals. You will have formula, but the formula is basically the relation. Like 1 kilometer equals to 10 to the 3 meter. These relations are there. So you need to know that. And here we have vernier calipers and screw gauge. These two. But it varies from school to school. Few school keeps it in the syllabus, few school omits it. But in practical, okay, in class 9 we have to submit practical. In class, those practical, these two concepts are required. But in some school, the section B or the exercise B is omitted. Okay, so I have not given any formula back, vernier calipers or screw gauge, but we have formula there. Okay, negative error and all, we have many things. And first, we have only the relation. And what I taught right now is from part C, the most important part, and I don't think any school will omit that part. Okay. And don't worry, from the first part, you will not have a, very tough concepts or something. You need to know the relations. It will come in MCQ, short questions and all. Okay. Or 3-marker question, but you will have subparts. So 1 mark each. Okay, chapter 2. Chapter 2 is motion in 1 dimension. Now in this chapter, I think 2 to 3 videos I have already made. So if you have not watched, go through it, you will have the full concept of motion in 1D. Everything is explained there. Okay. So in motion in 1D, we have many formulae. Okay. But I'll do only the important ones, which are actually required. First one, let's go through it. First one is speed equals to distance by time. We all know it. Speed equals to distance by time. From class 6 we are doing it. The distance traveled per unit time is speed. Keeping this in mind, we have another formula, that is velocity. Velocity equals to displacement by time. Speed, velocity same. Just the difference is scalar. Speed is a scalar quantity. Velocity is a vector quantity. Why? Because speed only needs magnitude for its expression. But here velocity, along with the magnitude, we also need the direction. So wherever direction is focused or wherever direction is required for its expression, we call them vector quantity. Displacement is also a vector quantity. Okay? Henceforth, velocity is vector quantity. What is speed, what is displacement, what is distance, I have explained there nicely. Please go through it. Okay. Next you have acceleration. So here if I say displacement per unit time is velocity in a particular direction, that part is important. Acceleration, these formulae very important. Velocity by time. Acceleration is the rate of change of velocity. Suppose at first instant the body is at 5 meter per second square. 5 meter per second, sorry. Second instant it's 10 meter per second. Third instant it's 15 meter per second. See? Fourth instant it's 20 meter per second. Okay? Then at fifth instant it's 25. So what is the rate of change of velocity? Okay, let's go till 30. What is the rate of change in velocity? We can say like this, 5, but we have a formula, that is this formula. Or we can also say v minus u by t. Okay, velocity by time, or more specifically v minus u by t. Acceleration is represented by a. V here is final velocity reached. U is initial velocity. And t is time, not writing. Okay, final velocity is 30, initial velocity is 5. So if I want to find the acceleration, then what will be the thing? 30 minus 5 by, suppose time taken here is, suppose for example, 5 seconds. 5, you will be confused. Okay, 5 seconds. In every 5 seconds, this is the change in velocity. So 30 minus 5, final velocity v, initial velocity u, right? Time t. So 30 minus 5 by 5. Done? 25 by 5. That is 5 meter per second square. Now don't think since this was 5, that's why time is also 5. No. It can be 10 also, like 10, 20, 30, 40, 50, 60. It would be like that also. Okay, if it is starting from 10, ending up in 60, means then 60 minus 10 by 5, if the time is again 5 seconds. So it's like that. Next we have slope. Now what is slope? Again this has been explained there nicely. What is slope, people? Suppose I have these two axes. Okay, I have these two axes. If I want to divide, suppose it's velocity time graph, for example. For the timing, I'm assuming you all know what is graph. You all have watched that video. For the timing, I'm assuming. Otherwise, I will have to explain again. Okay, please go through it. If you want to understand this formula nicely, then please go through those videos. Okay. For the timing, I'm assuming that you know what is velocity time graph. So for here, I have taken velocity time graph. Now, velocity by time. If I want to find out acceleration, what will I have to do? Velocity by time. So what I will do exactly? Velocity by time, right? So if I want to find the acceleration, that is A, I will have to do velocity by time. But here we cannot say velocity by time. We have to say y-axis by x-axis. Velocity is in which axis? Y-axis. Time is in x-axis. So this is y-axis by x-axis is called slope. Okay. The value on y-axis when divided by the value on x-axis, then we are calling it slope. Done. Next formula. Next, you need to sometimes find the area. Suppose if I have such kind of a graph, and if you are asked to find out the area of this, then what formula you will use? Obviously of a triangle. Suppose you have a trapezium. Suppose you have a square here. Forget this. Suppose you have a square here. What formula you will use? Area of square. So I am just writing about that. You will have triangle. You will have means different shapes it can have. A graph can have different shapes. Based on that, we have to basically apply the formula of that particular shape's area. So you can have square, you can have rectangle, you can have trapezium. Only these four. That's it. What are the formula? For triangle, base half into base into height. For square, it's side square. Side square, we already know it. These are the concepts of maths. Still I am saying here. Length into breadth for rectangle, and for trapezium it's half into sum of parallel sides into distance between the parallel sides. Done? Okay. Next, the most important formula on which the chapter is based. The most important on which the chapter is based. I have a different separate video on these three formulae where I have shown the derivation. We have two kinds of derivation for these three formulae. One is graphical method, another is normal derivation through different concepts, theoretical method. Both the things I have shown. Both the derivation I have shown. Okay. What are the three formulae on which the chapter is based? The most important, V equals to U plus AT. Final velocity equals to initial velocity plus acceleration into time. This is derived from this only. See? A equals to V minus U by T. I am showing, this is a small one, that's why I am showing right now. AT equals to V minus U. So AT plus U equals to V. So V equals to U plus AT, just changing the sign. Next formula, very important, it is of distance. S equals to ut plus half at square. This derivation I will not be able to show because it's a big one. There you see in that video. And the third formula is v square equals to u square plus 2as. S is distance, u initial velocity, half into acceleration into time square. Final velocity equals to u square, initial velocity square plus 2as, acceleration into time, distance into 2. Done? Nothing to explain much here. Okay, nothing to explain. This chapter over. Next, coming to the third chapter. And in the third chapter, you have many important formulae. But out of all, I'll only talk about the important ones only because you have many there. But I'll only talk about 6. I'll only talk about 6 here. This is chapter 3. Chapter 3 is laws of motion. First formula. Now, first formula is all the 3. Means the 3 which I have said, v equals to u plus at, s equals to ut plus half at square, b square equals to u square plus 2as. All these formulae is for both the chapters. Motion in 1D also it's required, here also it is required in some cases. Because those 3 are the fundamental formula. They are very important in physics. Most of the numericals you will find based on those 3 formulae only. Okay, henceforth you have to, like the way I have learned it, by practicing, but not by practicing. See, if you want to practice numericals, you are practicing in order to make your calculations and everything, concepts clear. But by practicing numericals, you will never be able to have a clear concept of the formulae. For that, you need to make a separate copy. There you have to write the formula 2-3 times and derive it at least 5 times. Then only you will be able to remember the formula. Okay? Because in the formula s equals to ut plus half at square, there are people who omit ut. Okay? The first part of the formula. But that will result in wrong numerical, wrong answer. Because the formula is only wrong. So that you have to keep in mind. Laws of motion. First formula of laws of motion is momentum. Momentum is represented by letter P. That is mass into velocity. Mass into velocity. Now what is momentum? Basically, momentum is the amount of force required in order to stop a moving body. Okay, that depends on the mass of the body and the velocity. That is the velocity with which the body is moving and the mass of the body. Okay, because more the mass, more will be the inertia, right? And if it is in a state of, means if it have some velocity, if it possess some amount of velocity, that means it is in an inertia of motion. Inertia of motion and mass, more inertia. So momentum is product of mass into velocity. Okay. Next, here rate of change of momentum. Here you have a different derivation on this chapter. I'll make a separate video. I did not make yet. There I'll explain the derivation of this formula. For the timing, you just know it. What is rate of change? Wherever you find the term rate, remember, just know one thing, that it is related to by time. Because whatever is given, suppose x is the thing, if it is rate of x, then x by time. Okay, wherever you have rate divided by time. But the formula is something different. See, what is the formula? I'm writing P here. It's rate of change of momentum. Mass into acceleration. Mass into acceleration. Okay, mass into acceleration. So now you will say, I've just now said rate means by time. Where is by time here? Now through a small derivation and through a small linkage of two formulae, means you have to link two formulae here, then at that point of time the by time part goes away, and in that case acceleration comes. But for that we need to know the derivation, for which I will make a separate video. Okay. Next we have force equals to ma. How much force to apply? That depends on the mass of the body and the acceleration of the body. Next formula is, this is again, I will not explain a single word about this formula here right now. It will confuse you badly and it will take away the interest of yours from physics, because it's a little bit conceptual thing, and if I want to explain it in a minute, then you will understand nothing and a fear will develop towards physics for the new ones who have just come to class 9. Henceforth, because I took much time in order to, catch hold of this formula, henceforth I am not going to speak a single word of this. There's no that there is a formula there. Let me tell you, F is force, okay. G is gravitational constant. What is gravitational constant? Has a value. I am not saying that. Mass into mass of both the objects by the distance, radius square. Okay. I know you have the urge to know, but still I am not going to say a single word. The next formula is weight equals to mg. Okay, there are 5 formulas. Weight equals to, in the beginning I said I will be talking about 6, but I am only talking about 5. Weight equals to mg, mass into acceleration due to gravity. What is weight? We all know what is weight, but we have a wrong conception. Mass and weight are equal, but it's a wrong concept. Mass and weight is never equal. Mass is something else, weight is something else. Weight is mass into acceleration due to gravity. That means the force with which the gravity is attracting each and every body towards its center. That is your weight. Okay? That's it. We are up with this chapter. Next comes upthrust. This is another bombastic chapter. Okay? So this chapter also we need to do nicely. Oh, sorry. Not upthrust. It's pressure. Upthrust comes after this. It's pressure. First formula in pressure is the thrust on a surface thrust on the surface equals to weight of the body. Only 3 chapters we will discuss for now. In my next video, I'll continue from the rest. Okay, this will be the last topic for today. because we have many formulae here. Okay, that too I'll not be able to explain all the formula of this chapter. Only 3 basic formulae we will do today, and in my next video I'll continue from here. Okay, so which is going to be the part 2 of important formulae. So thrust on surface equals to, I have to explain you this, equals to weight of the body. It's very simple. Suppose you have a surface and you kept a body on that surface, a box. Weight will pull it downward by its mg, that is mass of the body into acceleration due to gravity. So on this surface, what is a thrust? Now what is a thrust? Thrust is a force applied in a perpendicular direction. Thrust, whenever a force is making 90 degree with the surface, then it is called thrust. Thrust is also force, a special name has been given. Henceforth, a body whenever kept on a surface, then the surface, gets a force, it gets a thrust by that body. The body applies thrust on the surface. That is equal to its weight. Because no one is pushing it. So how will the force come? It is basically its weight, which is getting applied on this surface. Henceforth, thrust on the surface equals to weight of the body. Next formula is pressure equals to thrust per area. Now this formula is for normal solid objects. Normal solid objects. Because for liquids the formula changes. I'll come to that in another few minutes. Okay. But what I'll do is I'll only write about that formula. I'll not explain in great details about that formula because I want to make a separate video on that formula. Briefly, I'll talk about that. Okay. So, pressure equals to thrust per area. Basically, suppose you have area of 5 meters square. Okay, 5. It will be 16 meters square area, on which a force has been applied of 32 Newton. We know unit of thrust or force is 32 and that of area is meter square, right? So 32 Newton of force is getting applied on an area of 16 meters square. What will be the pressure? Pressure is basically the amount of force getting applied on a certain amount of area. So I have given you the scenarios. In that case, what will be the answer? Thrust per area, right? What is the thrust? 32. What is the area? 16. Right? I did not do anything, rocket science. Very simple. Thrust force is what? 32. So I have just replaced. Area is what? 16. I have just replaced. So 2. What will be the formula? It was Newton, it was meter square. So Newton per meter square, or in a better way we can write in this format. Newton n into m to the power minus 2. Okay. The last formula for today. Pressure equals to H rho g. You will find a separate video which I will make on this pressure. H rho g. H is the height or depth. Let it be depth. Rho is density of the liquid and g is acceleration due to gravity. Okay. So at a certain depth in a liquid, suppose I have a jar like this, filled with liquid. So at a certain depth, the pressure depends upon the depth, the density of that particular liquid. Suppose here if I take water, okay, then density of water, depth and acceleration due to gravity. A small last numerical, suppose H is Suppose 20 meter. I'm taking everything in SI unit. Density, suppose I have taken water. Water's density is 1000 kg per cubic meter. Okay, and in CGS it's 1 gram per cubic centimeter. And G, let's take it as 10 meter per second square. Then what will be my answer? Pressure equals to H rho G. I'm not solving it because very simple. We'll just multiply. So what we will do, replace value of H. I'm writing here. Okay? We'll replace the values. H becomes 20. Water 1000. This becomes. So now we will solve it non-linear. I'm not multiplying it. Okay. So hope you have liked my video. If you like my video, please like, share and subscribe it, and also press the bell icon for getting the further notification of my video. So in my next video, which is going to be the part 2, there I'm going to explain nicely about all these extra formulae and the other 2 formulae which I have just leave, since 36 minutes I've already crossed 36 minutes. Henceforth, those 2 formulae from this same chapter will be explained in my next video. And from there, we will continue with all other video. Okay, sorry, all other formulae. So till then, bye.